autoclaves can produce exceptional composite structures. But when drone production moves from prototypes to hundreds or thousands of airframes, the process also has to scale. Autoclave molding typically starts with pre-preg layup and vacuum bagging, followed by a controlled heat and pressure cure cycle. For toughened epoxy carbon fiber pre-preg, the published cure cycle alone can take roughly 4.5 hours, including heating, temperature holds, and cooling, and that does not include layup, bagging, loading, or unloading. Compression molding works differently. Composite material is placed into matched heated tooling, then formed and cured under controlled press force. Some fast cure press materials can cure in as little as 2 minutes at 150 degrees Celsius. These are not directly interchangeable materials, and autoclaves can process multiple parts in one batch. So cycle time alone is not the whole story. What matters is good parts per shift, labor per part, and total manufacturing lead time. For drone components such as battery boxes, propeller blades, access panels, and smaller structural parts, short closed mold cycles can support automation, molded-in features, and more consistent geometry from part to part. Autoclaves still make sense for many large, continuous fiber, highly qualified aerospace structures. But for repeatable components at volume, compression molding can change the economics. For manufacturers trying to build drones by the hundreds or thousands, compression molding isn't just an alternative process. It can be the difference between proving a design and producing it.